So hopefully everyone can see my screen. I've got a title slide up, Connecting the Dots on Climate Change, and you can hear me well. Okay, so some of this is based on material that I do cover in my sustainable engineering course. Some of it's a little extra material here. And what I want to do, I mean, everyone's familiar with climate change. Everyone's, particularly this week when we have both hurricanes and forest fires going on. And so everyone knows the basics. What I want to do is start out by a little bit talking about the science of how things are connected that leads to climate change. And then what are the responses? What are the reasons why we are not doing something about it right now? So let's start with the idea of a greenhouse. So we talk about greenhouse gases. We talk about carbon dioxide being a greenhouse gas. And the first question I want to ask is, why does it get hotter inside a greenhouse? It's something that we all take for granted, but what's really going on here? Glass is not unidirectional. If light can get in, it can get out. If heat can get in, heat can get out. So if you think about it, a greenhouse should come into equilibrium with its surroundings. But it heats up rather rapidly, and we know it gets much hotter in a greenhouse. So what's really going on there? We think of glass as being transparent, but light is on a whole spectrum of wavelengths. And so we think of things being transparent or opaque, but they're actually transparent or opaque to specific wavelengths. And so, for instance, you think of this greenhouse as being transparent. You think of my body as being opaque, but my body is transparent to X-rays and opaque to visible light. And so what's happening with a greenhouse is it's transparent to some wavelengths and opaque to other wavelengths. So we've got the electromagnetic spectrum, and visible light gets in. Visible light hits objects within the greenhouse, and when it hits objects, it loses energy. So it doesn't, and losing energy means that the light bouncing off of that object is now at a longer wavelength than it was. So less energy, longer wavelength. And so visible light comes into the greenhouse, hits objects, loses energy, bounces off at a longer wavelength, which happens to be infrared. And we think of infrared as that associated with heat. So for instance, when you are trying to keep your French fries warm, you put it under a heat lamp, and a heat lamp is an infrared lamp. So what's happening here, visible light passes through the glass because it's transparent. That light loses energy, is converted to infrared light, and then that's trapped in the greenhouse, and that makes it get hot in the greenhouse. So the first dot in connecting the dots is that infrared energy causes warming. So the next question that we would have is, so what's the connection between carbon dioxide and infrared energy? And to answer this, I'm going to use Amazon. So I can go to Amazon and buy a carbon dioxide detector. And the carbon dioxide detector actually uses infrared technology as its sensing device. So the relationship between carbon dioxide and infrared energy is so precise that we can actually measure how much infrared energy is absorbed and use that as our way of detecting the CO2 concentration. So without going into further detail, if I can buy this on Amazon for $138.90, it must be true. So we know that CO2 absorbs infrared energy. So the next question we want to ask, so if infrared energy causes warming and CO2 absorbs it, is the CO2 concentration in the atmosphere changing? And so we can put detectors, not quite like the one from Amazon, probably a little bit more sophisticated than that, but we can put detectors like that various places around the planet and measure the CO2 concentration in the atmosphere. And this is one particular observatory on top of a mountain in the middle of the Pacific Ocean. And this is the concentration of CO2 in the atmosphere over the last 60 years. And what we see is over this 60-year period, it's gone from about 320, and it's currently about 110. So it's gone up about 90 parts per million over the last 60 years. And it's currently, so the two things I want you to know is it's gone up by 90 parts per million over the last 60 years, and we're currently over 400. We're at about 410 right now. So if I compare that to a longer term trend, so this is data from ice cores in Antarctica, and this is the CO2 concentration that's been trapped in bubbles in a frozen lake, thousands of feet thick, in the Antarctica over the last 400,000 years. And what we see is there is and has been a natural variation in carbon dioxide concentration over time. So there's a lot of natural processes that lead to changes in carbon dioxide. So it's not only burning fossil fuels. That's not the only thing that causes CO2 to change. There's lots of natural things. But what I want you to see in this graph is that the range over the last 400,000 years has been between 200 and 300. And right now we're at 400. The other thing I want you to get from this graph is that it's gone from 200 to 300, or from 300 to 200, over a 100,000 year period. So the natural changes in CO2 concentrations happen very slowly over long periods of time. In retrospect, we've seen a change of almost this amount, 90 parts per million, in just 60 years. So although there's a lot of things that contribute to changes of CO2 in the environment, and there's a lot of natural processes, what we're seeing now is a much faster change and higher concentrations than we've seen in the recent history on Earth. So I can connect that to the next dot and say CO2 is increasing in the atmosphere. The next question we want to ask is there any way for humans to be contributing to these changes? So what we can do is go to our high school chemistry or maybe freshman chemistry and look at what happens when we burn some carbon fuel. So I'm showing a reaction here for gasoline. Now gasoline is a mixture of a lot of different compounds, but the compound I'm showing here is octane. Okay, so burning octane, I combine that with oxygen and I form CO2. So a gallon of gasoline, I know what the weight of that is. I can measure the specific gravity, so I know how much a gallon of gas weighs, and I can look at the stoichiometry and know that it's 87% carbon. So a gallon of gasoline has 5.4 pounds of carbon in it. I can multiply that by the stoichiometry of carbon dioxide to carbon and find out that burning 1 gallon of gas will produce 20 pounds of carbon dioxide. So then the next thing I'd have to do, the only thing I'd need to do is figure out how much stuff we burn on this planet. Not only gas that I'm burning and you're burning, but everybody, and coal and all other fossil fuels. So fortunately, I can look that up. So here we've got the key world energy statistics, and I give you the website where you can get that. And this has information not only on the United States, but on every country and how much fossil fuels they're burning. So here's some information, how much fossil fuels they're burning, and there's other information in here, how much they import and export. And there is information here on CO2 emissions. And so we've got a list of all countries here, and we've got for the whole world. So I can use this value to determine how much CO2 is produced to put into the atmosphere each year. So if I take the mass of CO2 that's generated by burning fossil fuels every year, and I divide that by the volume of the atmosphere, mass divided by volume, that gives me a concentration. So this is not a difficult calculation for engineers to do. I can take mass divided by the mass from that key world energy statistics divided by the volume of the Earth's atmosphere, and I get about 4.2 parts per million. Then I can compare that to the increase that we saw at the observatory a few slides ago, and we find that the annual increase is about 2.1 parts per million. So with just a simple back of the envelope, right on a napkin and a bar calculation, we can find that, yes, indeed, we do burn enough fossil fuels to account for the amount of increase that we're seeing in the atmosphere. In fact, it's a higher number. And the reason it's a higher number is because there's a lot of other natural processes that are happening. Some of that CO2 ends up in other compartments in the environment. It's consumed by plants, or it's dissolved into the ocean. So there's a lot of other natural processes. So connecting the next dot, we burn enough to cause the increase that we're observing. So finally, we do know from measurements, again, that the Earth has been getting warmer. And so this is a temperature trend over the last couple hundred years, and we can see that just in the last 60 or 70 years, the temperature has gone up about 1 degree C. So connecting all those dots, infrared energy causes warming, CO2 absorbs infrared energy, the CO2 is increasing in the atmosphere, and we humans are burning enough to cause the increase that we're seeing. The Earth is getting warmer, so we can connect the dots and say the Earth is getting warmer because of the infrared energy that is being absorbed by the CO2 that we're putting in the atmosphere. And so we can say that humans are contributing to climate change. Now, I'm not saying that we're causing climate change. It's not only one thing that causes climate change. There's a lot of natural processes, and those trends that we see over the last 400,000 years and differences in the climate millions of years ago. There's a lot of natural things going on, but humans are contributing to the change that we're seeing now, because the change that we're seeing now in CO2 is greater and faster than we've seen in recent history on this planet, and we can relate that to things that we are doing. Okay, so who cares? You know, if the climate's warming, so what? That just means we can grow more crops in Alaska and Siberia, right? I mean, maybe this is a good thing. Why is it a bad thing? Who cares if the temperature is one temperature or a different temperature? Well, the reason it matters is the current state of evolution is based on current environmental conditions. So the plants we have, the animals we have, they've evolved to a certain environmental condition, and they can only evolve so fast. And we are changing the climate faster than the normal rate of evolution. And so it has an impact on, you know, plants and animals on this planet. If we change the climate more rapidly, then they can adjust to that. But let's say we don't care about the birds and the coral reefs and the plants and the polar bears. Well, the other reason we should care is that modern infrastructure is also based on current climate, current environmental conditions. So when we build a city next to the ocean, it's based on an assumption that the ocean's at a certain elevation. And when we design buildings for a certain wind load, it's based on an expectation that hurricanes have a certain velocity associated with them. And if we design the heating and cooling systems in our houses, it's based on a certain temperature in the atmosphere. So as our climate changes, we're going to have to redesign and rebuild modern infrastructure for new environmental conditions, which is a huge amount of money. So even if we don't care about coral reefs and polar bears, there's a huge economic impact to people to changing the climate. So as some examples, this is Houston. So we expect a certain amount of rainfall, a certain amount of flooding. Statistically happens, you know, every certain number of years, and we can talk about the amount of rain that we typically might get in 100 years or 500 years. Well, Houston has had a high 500-year flood 3 times in the last 5 years. So we're currently seeing different climatic conditions. This is Venice. Venice was built at a certain elevation on an assumption that the water level was at a certain place, and now they're getting more and more flooding. California last year, this picture was last year, but I could have also taken this last week, right? We're seeing this again. We saw wildfires in Australia back in December and January. We saw them last summer in California, and now we're seeing them all over the West. Now, climate change doesn't cause forest fires. There's a lot of other things that contribute to the problems. Several decades of fire suppression has led to too much fuel in the forest. There's a variety of other conditions that contribute to forest fires, but they're made worse by having a hotter, drier climate. So they're contributing, the climate change is contributing to worse forest fires, even though it's not the only cause. Same with hurricanes. The function of a hurricane is to transfer energy, and energy gets transferred from equatorial regions to the north and south. That's what a hurricane is doing, is moving energy from along the equator to northern regions. And if we have climate change and we're getting warmer temperatures in the oceans along equatorial regions and more energy stored there, then hurricanes, we're going to have more hurricanes and more intense hurricanes so that we can transfer more energy further north. And this is a fully expected outcome of climate change that climatologists have been predicting for 30 years now. So what we're seeing is an outcome of the climate change that we're producing. Now, again, climate change is not causing the hurricanes, but it is contributing to making them more frequent and more intense. So, given that we can say that we're contributing to the problem and that these problems is having a serious impact on infrastructure in addition to the environment, why don't we do something about it? Well, we all know the answer to this, right? We can't do anything about it because it's going to hurt our economy. It's going to be way too expensive to do anything to address this problem. So we know that this is the reason from the stated reasons. So let me do a different share. And let me know, I'm going to play for a few seconds. Let me know if you can hear the sound.
Therefore, in order to fulfill my solemn duty to protect America and its citizens, the United States will withdraw from the Paris Climate Accord Thank you. Thank you. But begin negotiations to re-enter either the Paris Accord or in really entirely new transaction on terms that are fair to the United States, its businesses, its workers, its people, its taxpayers. So we're getting out, but we will start to negotiate, and we will see if we can make a deal that's fair. And if we can, that's great. And if we can't, that's fine.
So I'm going to play a few different sections here just so that you get a flavor of why we're not going to do anything about climate change.
Compliance with the terms of the Paris Accord and the onerous energy restrictions that is placed on the United States could cost America as much as 2.7 million lost jobs by 2025, according to the National Economic Research Associates. This includes 440,000 fewer manufacturing jobs, not what we need. Believe me, this is not what we need, including automobile jobs and the further decimation of vital American industries on which countless communities rely. Natural gas down 31%. The cost to the economy at this time would be close to $3 trillion in lost GDP and 6.5 million industrial jobs, while households would have $7,000 less income, and in many cases, much worse than that.
One more that I think is worth listening to.
This agreement is less about the climate and more about other countries gaining a financial advantage over the United States. The rest of the world applauded when we signed the Paris Agreement. They went wild. They were so happy. For the simple reason that it put our country, the United States of America, which we all love, at a very, very big economic disadvantage. A cynic would say the obvious reason for economic competitors and their wish to see us remain in the agreement is so that we continue to suffer this self-inflicted major economic wound. We would find it very hard to compete with other countries from other parts of the world.
Okay, so we get the idea why we don't want to do anything about climate change. It's going to hurt our economy, right? So let's talk about that for the rest of our presentation today. And so the first thing we want to do is understand a little bit about the Paris Climate Agreement. So couple key points here. First thing is every country except the Holy See has signed the agreement. The Holy See has indicated that they intend to join. The reason they haven't signed it is they are not currently a party to the United Nations Framework Convention on Climate Change, so they can't sign the Paris Climate Agreement until they've signed this other treaty. Honestly, the Vatican City doesn't have a huge number of coal-fired power plants anyway, so I don't know that they're a big contributor. And the United States intends to withdraw. The next key point is that each country determines plans and regularly reports on its own contribution. So each country decided what contribution they wanted to make, okay? And finally, the Paris Climate Agreement has no mechanism to force a country to set a specific target by a specific date. So what you just heard is that the reasons the other countries were excited that we joined is because they saw this agreement as a way to attack the United States economically. They were thrilled that we joined because it was going to hurt our economy. So the logic is that all the countries on the planet, so our traditional enemies like Iraq, North Korea, Russia, they got together with our traditional allies like Canada and United Kingdom and Australia. And just for good measure, they brought in all the other countries who don't care about the United States one way or the other, like Andorra and Gabon and Fiji and Montenegro. All these countries got together and decided they wanted to hurt the United States economically. And rather than doing it directly with tariffs or some kind of direct economic attack, they decided they would pass a climate agreement. And to be a little bit more devious, they decided that we could decide our own goals And then if we didn't meet our own goals, there'd be no penalties. So that's why the other countries were excited that we joined. This is their way of attacking our economy. Personally, I'm not quite seeing the logic in that. Now, one thing we want to think about is all the other countries agreed to make reductions as well. So the logic would be the reduction we agreed to make would hurt our economy, but the reductions that the other countries were making were maybe just very mild and not enough to hurt their own economies. So let's just look at one for a comparison. So the intended nationally determined contributions, the one from the United States says that we intend to achieve an economy-wide target of reducing our greenhouse gas emissions by 26 to 28% over a 20-year period. The European Union wrote they are committed to a binding target of at least 40% domestic reduction by 2030 compared to 1990. So starting with just looking at the language, the United States says they intend to achieve this target. We're going to try, and we're going to aim for 26%. The European Union is saying we're committed to a binding target of 40%. So just from a language point of view, you don't get the sense that other countries are doing this to hurt our economy and not expecting there to be an impact on their own economies. Now, the language here is different, but it's a little hard to compare the actual targets because I've got different percentages, different starting dates, different ending dates. So how do they truly compare? If we put them side by side, what we've got is in its base year. Now, I've done these numbers per capita. So this is CO2 per person in tons of CO2 equivalents. So the United States in its base year had 24 tons of CO2 per person. The European Union had 12. Now, it's going to hurt our economy for us to get down to 15 by our target date. But for the European Union to get from 12 down to 6, the logic would be that that's not going to hurt their economy. It's interesting to note here that when we get down to what our target was, the target that we made in the Paris Climate Accord, we won't even be down to what their starting point was. Now let's look at this a different way. So what I've done on this graph, each one of these bars represents one country on the planet. And what I'm doing is showing CO2 production per person. So again, tons of CO2 per person for every different country. So, oops, there's the United States. So you can see we have a fairly high CO2 production per person in the United States. Who's the bigger polluter than us? People say, oh, this must be China up here someplace. So where's China? There's China down there. So China's per person CO2 production is actually less than half of the United States. The reason they have more total emissions is they have 4 times as many people. But on a per capita basis, they're actually much lower production than we are. And some of those European countries, you can see where Germany, France, and Sweden are, they're all much lower than us. And so our stated position is for us to be lower than this is going to have a negative impact on our economy. Now, our target would be someplace in that range. So when we get down to our target, we'll actually still be above where some of these other countries are. Now, reducing CO2 is going to require new technology. It's going to require innovation and creativity and entrepreneurship and ingenuity. So the message that I take away from this is that our government believes that entrepreneurs in the United States are not capable of doing what entrepreneurs in other countries are capable of doing. That the strength of our economy is dependent on being inefficient. That if we try to be more creative and be more innovative, that's too hard for us to do. We can't do what other countries are capable of doing. now let me ask one other question. So people complain about, well, how can we predict what the climate's going to be in the future? What I want to ask you is, what is better able to predict the future? Climate science or economics? I realize we can't predict what the weather is going to be 3 weeks from now. What's the stock market going to do tomorrow? You know, for us to accept the claims that there's going to be so millions of jobs lost or what impact on our GDP, I would argue that economics has very little ability to predict how many jobs will be lost 10 years or 20 years or 30 years from now, or what impact it'll have on our GDP way into the future. I wonder why we accept those claims without even the littlest bit of thought as to how accurate they might be and how good those predictions are. I would argue that our ability, that our climate scientists have better predictive ability than economics. And we can look at historical performance as one basis for comparison. So we all know where New Mexico ranks on a whole variety of different categories, because various entities will rank states against each other and say this state is number 37th in education and that sort of thing. So it's possible for me to look up where every state is ranked in terms of its economy, how strong its economy is. I can also look up where each state is in terms of its environmental performance. And if strong environmental performance leads to poor economy, I ought to see a correlation between those two parameters for the states in the United States. This is what the graph looks like. I've got the state's environmental performance on the x-axis and its economic performance on the y-axis. And each one of these dots represents a state. Now, if there was a correlation between environmental and economic performance, these would all be on a straight line. I don't see a lot of correlation between states' economic and environmental performance. In fact, that would be the line that we're looking for. Good environment equals bad economy would be on that line. The actual trend line is here. If anything, we see a slight improvement in economic performance when a state has good environmental performance. And there's evidence to suggest that having strong environmental regulations leads to better economic performance. So to summarize, the climate is warming and humans are contributing to it. Burning fossil fuels is adding CO2 to the atmosphere. The concentration is higher than it's been in 500,000 years, and it's increasing much faster than it does naturally. The United States is the biggest obstacle to doing something about it. The United States is near the top in both total CO2 emissions and emissions per person. But more importantly, it's the only country that is withdrawing from the Paris Climate Accord. And this is important because of the impact it has on other countries. Suppose there's 100 countries and each contributes 1% to a problem. And all of them say, well, my contribution is an only tiny fraction, so I don't need to change anything, because if I fix my part of the problem, it won't solve the problem if the other countries don't contribute. So if everyone says that, the problem won't be fixed. But if every country says, I'll do my part, and I assume other countries will too, and all countries say that, then the problem gets solved. So we need two things. We need every country to do their part, and every country needs to feel reasonably confident that other countries will too. The United States withdrawal undermines that, makes it less likely for other countries to do their part. And it's really sad that the United States is the biggest obstacle. The United States has been a world leader on many things in the past, and with the right leadership, we could be the biggest contributor to a solution instead of being the biggest obstacle. And finally, the United States has a policy on climate change that's based on assuming that doing something about it is bad for the economy. And that's flawed economic reasoning. We don't have the ability to predict jobs or GDP 5 or 10 or 30 years into the future. Our ability to predict that is much poorer than our ability to predict the increases in CO2 concentrations in the atmosphere. Now, assuming that the United States economy depends on high emissions, is that we can't be as efficient as other countries really takes a dim view of American companies, that they cannot achieve what we are seeing happening in other countries. My perspective is the opposite, that the United States is filled with great American companies that are smarter and more innovative than other nations, and that we could easily outcompete other countries on reducing emissions. That our economic growth is not based on high emissions and waste and inefficiency. And finally, yes, we will see a decrease in jobs in the fossil fuel industries. But assuming that addressing climate change is going to hurt overall jobs or overall GDP relies on some very pessimistic assumptions about our economy. You would have to assume that no American companies and no American entrepreneurs will create any inventions or any new technologies that will create jobs. I don't share that negative view of American companies and workers that our administration does. I think that the innovative spirit and creativity of our entrepreneurs would be unleashed and that many more jobs would be created, and we would see an increase in our GDP. And with that, I'll open it up to questions. Here are my photo sources that I've used throughout this presentation. Thank you.